Today we will be exploring a topic prior to jump into the actual topic that we were planning to today. So Matt here and Q were talking about pipelining, transaction pipelining or chaining. So let's at least let's explore like an intro on that topic. Okay. So let me. Okay.
I'll take care of sending some tweets out of the video on
Thanks.
YouTube in just a minute.
Yeah, I was doing exactly that. It's on Spanish, but it's okay. I guess people will understand it. Okay, now we will start with this. So wait. Let me know if you're watching.
I am.
Perfectly okay. Nice. So I will switch to this wallet today. And okay, for doing pipelining or transaction chaining, I don't know, Matt. You have not seen this language before, this game changer scripting language. Is your first time with it?
It is, yeah.
Yes. Okay.
Yeah.
Okay. So, how can I make a quick intro? Okay. This is a low-code JSON-based scripting language that ultimately is going to be packed into URLs. This is the current transport medium for this the app connector that GameChanger has. Is the current one, the only the app connector that we have right now works with URLs. The nice thing about this technology is that in the future this can change. Okay, we can have more than one medium, so you can choose between URLs and maybe something more similar to browser extension wallets. Okay, so this is the thing, but the idea of this scripting language, that is actually a DSL, a domain specific language, is to ultimately give orders to end users wallets. Okay, in this case this is like my wallet, and I will be giving orders to my own wallet from here, because this what you're seeing here is like the programming interface, the coding interface, the IDE of the wallet. Okay. So basically, it's pure JSON. Basically, the basic thing on the language is this property called type. So every like function of this API or of this language will involve like a JSON object with a specific type. When we say TypeScript, it's like a block of code. And inside the run property here, we can nest other functions or elements of this, of this language. We can nest more blocks of code or call another functions. So this is a very quick intro. There are more videos I can share to you if you need to get deeper into this. But for example, you have a lot of examples here to get started quickly with different topics. For example, this one is the most common one. Um, maybe the most the most common use case, that is making a payment, making a transaction that will make a payment on, to someone else. Um, to go quick over this demo, you have nested inside this root block of code. You have like these three stages, or I mean 4 stages. You are first building a transaction, then you are signing the transaction that you have built, and then you will be submitting the signed transaction. And at the end, you will prepare like results to deliver back to the app or to the wallet ID, this playground thing. So here on the build stage, we are using this build transaction type of function of the API, and basically you define your transaction with JSON. So for example, here you have one output. This is the list of outputs, and you have an address here and the assets that you're sending. In this case, one ADA is expressed in Lovelaces. Okay. So the thing is that this, of course, will generate a new UTXO on this address. Okay. So and this function creates a single transaction. Okay. But the signing function of the API receives a list of transactions to be signed. Okay. And the submit function receives also a list of transactions to be submitted. This is a multi-transaction native API or functions. Okay. Because you deal with multiple transactions at the same time. Here, this is actually a list. These are like tiny macros, tiny like how can I say, like are you, Matthew? I mean, are you a developer? You know.
I'm I'm good enough to break something.
Okay, I mean, but you know a bit of programming.
Oh yeah, absolutely. Yeah.
Okay. I felt that was the case. So this is like, I mean, it's like if every stage, every piece of the code is like, if it's like it generates like a variable containing the results of each piece of the code. Okay, variable where you store the results of each of these pieces of the code. This is not entirely true, but for now, let's keep it simple. So what this does is access or connects these tiny codes here, connects to the results, for example, to the previous results. In this case, we are like uh, pipelining or connecting the results of this function that signs transactions to the submit. This is the explanation of these weird lines here. So this involves a single transaction, as you can see here, a single transaction, the single one that is being built here. If we go to let's explore this example. I don't know if it's very old, if it is deprecated, or if it's not useful for this. Let me check. Let me check. No. Okay, this Actually, this example is called pipelining or something like that. Yes, pipelining, but it's not reusing the previous UTXOs generated on previous transactions. Uh, Maybe we can explore the uh, let me check. Yes. So this example, the run Bluetooth script example, will be locking some funds on a smart contract address, and then will be redeeming, unlocking those funds. Um, Forget about all this prelude here, all this setup on the code. Let's quickly jump into the build transaction that is the same function that you have been seeing on the first example I showed. Here we are making an output to this address here that actually is a smart contract address. Okay, these are datums. Forget about this. Let's think about the basics. You are sending to this address these assets. Okay, on this first transaction, and then we are signing this transaction, and then we are submitting this transaction. Then, and at this stage, we are building a new transaction that will use as inputs here, as you can see, it will use a UTX, one of the UTXOs generated by the previous transaction. The transaction hash that we are using on this UTXO is gathered from this from the previous block of code. There are some. I know you want to say something, Matthew. Just let me do. Let me say something regarding this. Um, it's not very difficult to make game changer consume blindly. Without checking into the actual blockchain UTXOs. Probably not. Now you can be doing this kind of scripts to pipeline to connect some previous UTXOs to consume them on new transactions. If I manage to unlock this actual check, what it this check actually is not a check. It's going to fetch the actual UTXO from the blockchain, the assets, the datums, whatever is in it, and will use it to build this transaction. I can like release this dependency and make like use unchecked UTXOs that maybe they don't exist. If I do that, we can actually be, for example, signing a list here of transactions that can be consuming previous UTXOs, because um, that way we can be maybe doing pipelining in this way. Without submitting the transaction and fetching the real UTXOs from the blockchain. Maybe if this was a doubt, I have cleared it out. Please go on. What you wanted to say?
Yeah, that was the question. Really, was how could you possibly? I guess the use case, the simple use case. Let's say that you're minting NFTs, and somebody sends ADA to you, and then you have a little bit of dust left over, and you would like to every so often gather up the dust and use it for a transaction. And so you need to have hundreds of inputs and one output that would be sort of the cleanup of all of it. And so you would need to then also, if you were to use it later, you would need to know what that would be. Or otherwise, what if you were also, you were building NFTs into airdrop. So you need to consume a UTXO, and then you have change from that UTXO, and you see if you meant 10, 20 NFTs at once, then you'll have a change output, and you can drop that change output, and you can pre-create the transaction that gathers the UTXOs into one. So you can do kind of similarly that type of action. You'd want to build the transaction before you submit the first transaction, because you don't want to necessarily wait. And then you can go, think about if you have one UTXO that's got hundreds of or thousands of ADA in it, you want to split it into hundreds of UTXOs that can each be used to mint. Each of those then in parallel mints, and you have a third transaction that gathers up all of the change outputs from the second transaction. So what you would want to know how to build that third transaction before you submit the second transaction, before you submit the first transaction that splits all the UTXOs up. So you'd want to be able to sort of cascadingly figure this whole workflow out, from one UTXO to many, to send, to gather, and then end at one UTXO again at the end of the process. So having that chain is a very useful thing to be able to do. And it's interesting that GameChanger does that.
That's perfect. I mean, I get it, and yeah, it's a matter of priorities. I was like prioritizing other work first, but there is an idea of taking or faking UTXOs snapshots. Okay, this is the future of this API. Is if you ask me today. So the idea is to generate real or fake UTXO snapshots that you can use as inputs on new transactions. This will unlock a lot of use cases, like the ones you ask, and much more. But yeah, the thing is that the nice thing is that it's just extending the API and unlocking this this real UTXO fetching from the ledger, from the backend of the wallet, and use user-defined data instead. And it has to. I mean, it's not just about assets. Now we have datums, we have a lot of other information that we need to have support here, right? If we are going to be faking or generating this UTXO data, we need to do it completely like the protocol, how it is on the protocol. So. But yeah, I mean, the nice thing is that this is the only thing missing. There are some cases. I mean, if we, okay, I don't think we will have the time. But for example, if you go, I invite you to try this out. Please do it. So if you have funds on your wallet, and if you have like I say, always a healthy UTXO set. You have several UTXOs ready to use on the wallet, not just one. You can go, for example, on deploy this tab on the playground and read this. If you're on desktop, you will be able to read it. This is a nice intro of this technology. So this
Thank
thing.
you, Adriana.
Okay, Matthew. I mean, this thing will create like how can I explain this? Uh, a group of transactions to store files on chain. Okay, with a protocol
Mhm.
and a specific protocol that this thing is using called Game Changer file system. So the the thing here is that you will be checking how this API and the wallet handles um, booking or reserving for UTXOs properly to allow a multi-transaction operation. So by this, I'm saying that even if I unlock this UTXO feature that you are needing, you have these other features already built on the wallet that will help you because I mean, the idea of Game Changer is avoiding you doing all the UTXO calculations always by yourself. Um, with this, with the features that we already have, you can just build a set of transactions without caring about overlapping or trying to double consume the same UTXOs. The wallet will handle this automatically. Okay, this is what I was trying to tell you. And a way
Yeah, I
to
love it.
checking out is doing
I'll
this.
take a look at that. I'm sorry, I do need to go to catch another meeting, but thank you for the time today, and it's good to speak with you, Adriano. Quasar,
Okay,
be well.
thanks for coming, Matthew. Okay, guys. Well, um, what can we do in this half an hour? Do you want guys to explore the topic of the day or something else?
Um, totally up to you here. I'm a bit busy writing the tweet about what we were doing here. So
Okay, let's do it quick. So we uh, we kept our promise for today's topic. I will be covering this thing quickly. Huh. Okay, I will be reusing this wallet. Um, okay, the idea of today session was to um, we are used to this to the Cardano Catalyst funding um, uh, flow where you receive sometimes you receive payments on Cardano for each of your funded proposals if you get lucky and you get the funding, and it's always a mess. At least I can tell this from my user experience. It's a mess receiving these funds on any other wallet out there, because it's not human friendly enough. The address handling. It's like a mess when you can generate, of course, several different addresses with your same mnemonics. Okay, but then if you want to make a transaction, the wallets are going to automatically grab funds from any of your different addresses or sub accounts on your wallet to make a new transaction. So all the balances are going to get mixed up. It's going to be a mess. The other solution is to generate one mnemonic set for each funded proposal. But if you need to handle more proposals, it's very painful to handle all this information. And the more mnemonics you handle, the more times you deal with mnemonics, you are risking it. Um, you're risking a lot. So the idea is to reuse the to make a proper management of your funds. And this is what we are going to be doing today. So we don't have much time left, but I'm going to start by okay. I'm going to start by tweaking this demo so we can go fast. Manage out. This is the title and the description of the script we are doing. We're going to say catalyst there. Actually, these two things controls the result of the script. So in this case, it's not very important. I'm going to leave it this way. I'm going to draw up this thing. And okay, here I'm going to remove this part of the code. And okay, here we're going to be using as this code, as this block of code is called wallet setup, we're going to be setting up our wallets. Okay. To set up a wallet, we actually underneath we are going to be dealing with this concept called workspaces, where you can set up your wallet with keys, addresses, and other kind of items. To do this, there are two functions, load config and save config. In this case, we're going to be using load config to make it quick. Okay. Here we're going to say catalyst. So every time we use load config, we have to define like an update ID. This will help the wallet to identify updates on your current wallet setup. Okay, if you change this ID, sometimes this will trigger some messages on the wallet to help you deal with this event. Okay, so this load config function requires layers of configuration. Okay, layers are lists of specific type of items that we can set up on our wallets or end users wallets. I mean, remember, what I'm going here is going to affect this wallet, but I can easily turn this into a DApp that will generate the same kind of setup on end users. Okay, so first we are going to create a workspace. What I told you, this group of items is called workspace. In this case, we're going to name this workspace with an internal name, okay, that then we are going to be referencing. We are going to say just catalyst, okay, in lowercase. Here we're going to say catalyst funds. This is the title. And we're going to say here wallet settings. Managing if you think about it, Of course, this will be based on Catalyst, but this can be a merchant's wallet to deal with several customers' payments, maybe recurrent or not. You can create different addresses to deal with different customers, different merchant orders, whatever. So this is just an example, but it's the same use case. Okay. So we have on this layer created one item of type workspace. And these are the parameters, the arguments of this workspace. Then, now on another layer, we're going to be creating different keys. To create a key is actually called deriving keys. Okay, we are going to be creating child keys from our master private key on the wallet, or to say it our way, out of our mnemonics. Okay, so in this case, we have created here a workspace with an internal name called Catalyst. So here, when we are going to start like allocating items inside workspaces, on the list of workspaces IDs or names, we are going to be using the same internal name. Okay, Catalyst in lowercase. Remember, we are going to be creating child keys. Why we create child keys? Because very quickly, I don't know if you are watching this. Yes. So okay, an address on Cardano can be referencing, for example, two different keys, a spend key and a stake key. These are like permissions. Whomever has the private key, okay, of the public key referenced here, because keys came in pairs, the public and the private one. Whomever has this pair of keys on the wallet can spend funds from this address, and whomever has the stake pair of keys can delegate, for example, or change the delegation, withdraw rewards from the delegation, whatever. These are like permissions. So this is why we derive keys. We derive keys because this way we can customize how we want to deal with addresses. And we can create addresses. I mean, in this case, what we're going to be doing is generally, I'm going to be using these indexes to make it fast for today. But what we are going to be doing here, if we go to the theory very quickly, these all are standards that are accepted on Cardano. This is the BIP 32 specification or variation of this specification that works with Cardano. This is a way we can agree upon the recipe on how to derive keys. Okay, and this involves in a sequence of numbers. Okay, after this M, these are a list or a sequence of numbers. Basically, these are the base chain derivations that we use on Cardano. This refers to the account index that we will be seeing on the code, and you can check accounts, for example, on wallets like Eternal. When they say account 0, account 1, account 2, they are dealing with this index, this number. When we want to differentiate a key for being a spending key or a staking key, okay, or maybe an internal spending key, as I like to call it, we deal with this index, this number here. And when we have several addresses under the same account, what we are changing, or what wallets are changing, is this number. This, as it says here, when on the hierarchical deterministic recipe on how to derive keys, what we change in a sequence is this last address index, this index here. So we start with 0, then we have 1, 2, 3, 4. Each of these keys will allow us to generate, for example, a sequence of addresses that can be rebuilt on some other wallets on the ecosystem that handles the same standard. Okay, this is a standard for hierarchical deterministic wallets. Bitcoin uses this as well in a different way, but uses the same thing. And on Cardano, we are using, wallets like Eternal, Yoroi, Daedalus, all of these use the same hierarchical deterministic recipe to derive keys. The thing with GameChanger is that it allows you to move freely on this space, to adhere or not, agree or not to these standards, and to handle these features on yourself, because sometimes you need to get out of the standards. One example for getting out the standard could be to do multi-delegation. Okay, you can have multi-delegation still adhering to the hierarchical deterministic recipe of derivation, but sometimes it's too much. Sometimes users just need, like, I don't know, 3, 4 addresses to deal with, not entire accounts, not dealing with a lot of addresses without any tag, any human-friendly name or tag to reference it. So on GameChanger, we give you wings to choose your strategy and to set up your wallet addresses as you want, and also to DApps, because maybe, for example, maybe an SPO or an SPO alliance can create a simple DApp to generate like a delegation portfolio on user wallets. And with just one click on a GameChanger URL, SPOs can do these kind of setups on user wallets, putting names to these addresses. Okay, so going back to this thing that we need to solve, we're going to do this. Let's grab this number that we have here on these Catalyst proposals. Let's grab this number that is a unique identifier for each proposal on Catalyst. And let's break on purpose the standard. Let's not do a hierarchical deterministic wallet here. Let's do a derivation recipe that, to keep it simple for us, will reuse the exact number that Catalyst uses. Okay? So under the account index 0, that we're going to leave that way, we are going to use, for example, the exact same ID or number that this Catalyst proposal show us here. And this is the name of the proposal, and we are going to be using the name here. Let's do something different to keep it simpler. We're going to be using the same number, okay? And we're going to use something a bit complicated here to make it more interesting. When you read pattern on GameChanger, it means that you have available variables to use. In this case, if you use kind, you use this variable here between these curly braces, you can this will be automatically replaced by the kind here, spend. Okay, the kind of this key. This key is going to be of kind spend for spending key. Okay, so we have now our first spending key. Now we are going to do the same with a stake. What we are going to be doing here is that we are going to be doing a multi-delegation automatically for each of these addresses. We are going to allow them to multi-delegate to different pools, okay? Just because it can be useful. So the only difference between this key derivation and this key derivation is the kind here that we're using spend and stake, okay? So now we have two keys that will allow us to generate an address. Now I'm going to use this other ID. Okay. The same thing here. Same thing here and the same thing here. And then one more. And Martin will remember this. We will be deriving is the last product. Okay, I'm going quick. I hope to be getting this okay. Yeah, it seems so. Okay, so we have now all these keys prepared for derivation. And now, okay, we don't have enough time, but the idea was to create also a shared treasury for a co-proposed proposal, like for example, the one we did with Martin there, the Cardano total. This can be doable. I mean, this can be done. I'm sorry, but for time reasons, we are going to skip that part of this session. So remember, on this layer, we were dealing with keys. Now, on this layer, we will be dealing with addresses. Okay. Once again, we need to put these addresses inside this workspace called Catalyst, and check this out. On the list of addresses that we will be generating, now we can, for example, reference these keys, okay, with the name of the keys, okay? So in this case, we have instruct the wallet to use a name pattern to name the keys this way: the kind of the derivation and these IDs. So this will be end up being, for example, spend, okay, and that number. Yeah. So what we are going to be doing now is to actually use the resulting names here to reference um, the previous keys that we have been generating. Here, of course, we will be using stake. So check how the spend prop key name references an spend key and the stake references a stake key. So now, wait, let's go one item at a time. This proposal was named Smart Contract Support. Today, because we are not going to be using these addresses for something else, I am going to be using spaces, okay? Spaces on these name patterns, okay? On the addresses. But keep in mind that if you handle names like this, okay, without spaces and with these low, these characters, this will allow you to reference these addresses, for example, later on code. Okay, so this is a good practice. This is not a good practice, but to keep the addresses human readable, we will be doing this right now. Today. So this will be our first address. Now we are going to be setting up another address that was the one with this ID and was oops. And then one more. The last one was Cardano Totem. And this was the ID. Okay. Before 72. Okay. It seems to be okay. So now we're going to save the file. And okay, we are theoretically done right now. We can try to run this code. Let's see if it's valid. And yes, it's valid. So the title, Catalyst Management, managing Catalyst funds individually. Okay, so if we run this, we have this warning that says only script stored on GameChanger file system by yourself, okay, can call load config endpoints. Load config or no, not load config, okay, not the other one. So the wallet says that has prevented identity unknown to give orders to the wallet to continue may lead to loss of funds and other issues. This means that for using load config, we actually need to call load config from a script stored on GameChanger file system, because that way we can prove that we own that file, that we have created that file on chain, this code on chain, meaning that we are the owners of that code and the code can be trusted by the wallet. So here, because we are not doing that process right now, that step, because we are just trying this code locally and quickly on the wallet ID, the wallet is warning us. Okay, so in this case, I'm going to say continue, but be careful because this is a very powerful feature. To be allowing third-party entities to set our wallet configurations. So it's important to read all these warnings. Okay, we're going to be continuing. Now, very quickly, it says, okay, you have clicked continue. Please back up this wallet setup. Okay, because otherwise you may lose the recipe. Okay, and I'm going to click continue, and that's it. Okay. If I continue, if I capture the results of the script, we have no results because we instruct the wallet here to return nothing. Okay. So this seems to be worked. It worked. So let's go to the start, to the dashboard of the wallet, and let's check the list of workspaces. And at the end, we have a new workspace now that it says Catalyst Funds, wallet settings for managing my Catalyst funds. Okay? If I select this workspace, we are switching to this workspace now. We are applying this configuration. And if I change the current address now, we have individually all these three addresses to receive separately the funds from Catalyst, to even delegate to different stake pools each of these funds, and to interact. For example, imagine that we have funds here. So imagine that you need, for a crazy reason, to move funds from this from this address to maybe Cardano Totem project. We can go to Smart Send, and here on the list, on the address book of the wallet, we have these addresses available here. So for example, we want to move funds to Cardano Totem. By clicking on Cardano Totem, the wallet now automatically chooses the address. And if I click continue, providing that you already have funds here, you can start picking and sending assets elsewhere. But now in a very human-friendly way. There are no more addresses. You don't have to remember these addresses. You have them here. And by just clicking, you will be switching to these different addresses. Of course, you can copy them here. You can generate a QR code here. Okay, for this for all these addresses, and you can even delegate. You can choose a pool, for example, and delegate each of these funds to different pools at the same time. We could be setting up this to delegate to the same pool, and just to show you how this can be done, it's very simple. We have been creating these different keys, these different stake keys. Okay, here. Imagine that we use the same one. We can say, just for example, we can say here, and we can choose, for example, the number 0. Okay, and that's it. And then we can delete this one here, delete this one here. Okay, and when we reference here the stake key, instead of handling different stake keys, of course we can say stake, right? Stake com. And this way we can make the three addresses to be delegated to the same pool, meaning that if you construct a single delegation transaction, a single transaction to delegate from any of these ones, of these addresses, all of these addresses will be delegated to the same pool. Okay, so this is it. The last thing, the bonus part here would be to change this as save config and to remove this update ID. And okay, I have this changed with the common stake delegation. I have not checked this, but it should work. So if I hit run now and I click continue, what this is going to be doing is to create a wallet configuration file on chain. So if I pick a new password here, because this is going to be the password for the encrypted file, it's going to be encrypted on chain. You can click continue. This is going to ask for funds to create a series of transactions that will store this setup on chain. This has failed because if we check, we have 0 ADAs here. We don't have funds to generate these transactions. Okay, but basically by changing this to save config and removing that update ID, you are storing this configuration on chain for later reuse. Okay, so then you can pair all your devices with the same setup. So you can be on the phone and check your funds. You can be on the desktop and check your funds. The same addresses, of course, provided that you have imported the same wallet, the same mnemonics on all these devices. Okay, well, this is it for today. Of course, we are on pre-production testnet right now, but hopefully for Fun 10 we will be on mainnet on the funding stage of Catalyst, and maybe people can handle their funds this way. Remember, you can even have shared treasuries here to deal with co-proposals. Okay, so that's it, guys. I don't know if you're still there. What do you think?
I like it. Let's do it. Go ahead, Martin.
Yeah, cool.
Okay, guys. Well, I'm going to stop streaming right now. So thanks for coming. Hopefully you're watching this. Let some comments down below if you're on on YouTube or maybe on Twitter or on Discord. Let us know what you think about it, and maybe try it. I will try to leave the code on the video description. Thanks for watching.